Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will start a new series on deep learning. So mainly how we can easily use the different types of deep learning model to identify the different types of image analysis, mainly image classification, image segmentation, and object detection using the deep learning. So all of those things I will try to complete one by one. So basically today is our introductory part, mainly what is the deep learning and how we can easily train our model using the deep learning. So basically deep learning is a vast topic. So that's why I will try to upload all of those things sequentially one by one, not complete in one video. You have to just keep in touch with this YouTube channel. Then you can get the some further more advanced tutorial. And if you want, you can also join my online training program, mainly live training session on deep learning to learn the land use land cover classification as well as the segmentation and object detection using the deep learning model. So let's go. We try to start our first class on the deep learning. So basically today's session, I will try to discuss about that what is deep learning, then what is artificial neural network and difference between the machine learning and deep learning, and then types of neural network and application of deep learning, then advantage of deep learning as also disadvantage of deep learning, and how to make dataset for train the model of deep learning. So first of all, what is deep learning? Basically, deep learning is the branch of machine learning which is based on artificial neural network, and it is a branch of machine learning, and basically it's capable of learning complex patterns and relationship within the data. And deep learning is a machine learning subfield concerned with the algorithm inspired by the brain's structure or human brain's structure and a function called the artificial neural network. An artificial neural network, its short form is that ANN, uses the layers of interconnected nodes called the neurons that work together to process and learn from the input data. So further, we also try to discuss more details about the ANN, mainly artificial neural network, and how it will be work. And these neural networks are inspired by the structure and function of the human's brain's biological neuron, and they are designed to learn from the large amounts of dataset. And some of the popular deep learning model, including the convolution neural network (CNN), recurrent neural network (RNN), and deep belief network, mainly DBN. So all of those neural networks I will try to explain in this video tutorial. Not only for this part, further I also upload the more tutorial. So keep in touch with the channel for getting the more update tutorial on the deep learning. So in this time, artificial neural network. What is the artificial neural network? So basically, artificial neural network are built on the principle of the structure and orientation of human neurons. It also known as the neural network or neural nets. So we can get this type of nets here. You can see, and it can be divided into input layer. One is the input layer, another is the hidden layer, and also output layer. So hidden layer, not only for a specific number. Hidden layer can be 2, 3, 4, 5, 6, or more. Okay, hidden layer can be different on our project. So it can be 2, 3, 4, 5, 6, no, all of number, no problem. But input layer, it's mainly receive the information. Okay, input layer mainly receive the information, and artificial neural, also known as the units, are found in artificial neural network. The whole artificial neural network is composed with the artificial neuron, which are arranged in the series of layer. We can get the input layer, then hidden layer, then output layer. Okay, in fully connected artificial neural network, there is an input layer and one or more hidden layers connected one after that other, and each neuron receive the input from the previous layer, and neurons of the input layer, the out of one neuron becomes the input other neuron in the next layer of the network, and this process continues until the final layer produce out of the network. So basically this is the process to input layer take the information and then give the hidden layer. Hidden layer also have some other, and also get the output layer. Okay, so this is the process about that. So further, we also already discuss more details about the artificial neural network. So this is the figure about the artificial neural network. Mainly, we can get the input layer. Input layer give the information. Hidden layer, basically, it can be more than 2, 3, 4, 5, 6, 7. There is no any specific constant value. And finally, we can get the output layer. Okay. So in this time, we talk about the difference between that machine learning and deep learning. So machine learning and deep learning both are subfield of artificial intelligence, but there are many similarities and difference between them. Here you can see about the chart. Machine learning mainly it's the apply for statistical algorithm to learn the hidden pattern and relationship in the data set. On the other hand, deep learning uses artificial neural network architecture to learn the hidden pattern and the relationship in the dataset. Deep learning can work on the smaller amount of dataset, but for the deep learning, you need the require the large volume of dataset to compare to the machine learning. So basically, when you want to work for the machine learning, then you can easily work for the small amount of dataset. Suppose you can take only for the 30 sample of training point, and you can easily work with that. But when you want to work for the deep learning, you need to require the large volume of dataset compared to the machine learning. So deep learning better of the low level tasks, and when you want to work with for that better for complex tasks for the deep learning, it can be image processing, natural language processing, and extra. Take less time to the train the model. So basically, it take less time, but deep learning take more time to train the model. And model is created by relevant feature which are manually extract from the image to the detect an object in the image. But on the other hand, deep learning relevant feature are automatically extract from the image, and it is an end-to-end learning process. Less complex, easy to interpret the result by machine learning. By the deep learning, it have the more complex. It work like the black box interpretation of the result are not easy. Machine learning, it can work on the CPU, central processing unit, or require the less computing power as the compared to deep learning. But when you want to work for the deep learning, you must need the high performance computer with GPU. Okay, then we can easily get the better performance with that deep learning. So basically, this is the common difference between that machine learning and deep learning. But it also some a lot of similarities and also have some lot of differences. Okay, so let's go the further. In this time, we talk about the types of neural network. So basically, deep learning models are able to automatically learn feature from the data and which make them well suited for tasks such as we can easily do for the image segmentation, image detection, as well as also natural language processing, and there are a lot of things. And the most widely used the deep learning model, it can be convolution neural network. Okay, it mostly used, and also recurrent neural network, mainly CNN and RNN, as well as we can also use for the FNN. It's the feed forward neural network. Mainly, it's the simplified type of ANN with the linear flow of information through the network. FNN have been widely used to tasks such as image classification, speech recognition, and neural language processing. And convolution, it also used for that different types of image and video recognition. CNN able to automatically learn the feature from the image, which makes them the well suited for the tasks for the image classification, object detection, and image segmentation. We can easily do using the CNN. So further, I also try to discuss about the practical example about all of those things. And recurrent neural network, mainly RNN, it's one kind of neural network that is able to process the sequential data such as time series and also natural language, such as when you want to work for that LSTM, it also work for that, as well as also language translation. There's also a lot of use. So basically, in this time, in my this series, I'll focus on the CNN and also focus on the RNN. Okay, so these two algorithm I will try to explain one by one, and also use a lot of practical example such as image classification, object detection, image segmentation. So further, we try to discuss a lot of practical things. I hope you can easily learn all of those things. And application of the deep learning. The main application of deep learning can be divided into computer vision, natural language processing, and the reinforcement learning. So there's a lot of uses such as object detection and recognition. We can easily do using the deep learning, and then image classification. okay, and also image segmentation. Okay, so all of those things I will explain further tutorial how it will work. And also it has some challenges such as data availability. So basically when you want to apply the deep learning, you need the large amount of data. Okay, but machine learning, it can be capable for a small amount of data, but for the deep learning you must need the large amount of data. And computational resources, you must need the higher computational resources such as GPU you must need, otherwise you did not get the better result. But machine learning we can easily apply with the CPU. Okay, and time consuming, because while working with the sequential data, depending on the computational resource, it can be take very large even in the days or month. Okay, but machine learning work very fast. And interpretability, deep learning models are complex, it work like a black box, it's very difficult to interpret the result. And also overfitting, when the models is trained again and again, it become too specialized for the trained data and leading to the overfitting and poor performance of a new data. Okay, so this is another challenges. Okay, and how we can easily overcome this type of challenges further, I also try to discuss about that. And advantage of deep learning, so basically we can get the higher accuracy. Suppose you want to make the crop classification, as well as you can also make the species classification or segmentation or object detection, then you will get the high accuracy when you want to apply the deep learning. But machine learning, we are not get the higher accuracy. Deep learning provide you the higher accuracy for the image recognition, image segmentation, image classification, all of this in the higher accuracy. And automate feature engineering, deep learning algorithm can automatically discover and learn the relevant feature from the data without the need for manual feature engineering. And also scalability, deep learning model can be scaled to handle the large and complex data set, can learn from the massive amounts of data. And flexibility, deep learning models can be applied to a wide range of tasks and can handle various types of data such as image, text, space. So basically in this time we are work for the images, different types of satellite images, aerial photography, drone images. So these type of things included in here for our subject. And continuous improvement, deep learning models can continuously improve their performance as more data become available. And disadvantage is also some, because it's need the high computational resources. Deep learning, when you want to for that deep learning, we need the high computational resource requirement, and also need the requirement the large amount of the level data. Mainly when you want to take the training sample or label data, you need the large amount of label data for the training, otherwise you did not get that better result. Okay, so deep learning, when you want to work with that, you must need the large amount of label data or pre-categorized data, otherwise you did not get the better result. And then interpretability, which deep learning models can be challenging to interpret, making it difficult to understand how they make decision. And overfitting, deep learning models can be something overfit to the trained data and resulting in poor performance on the new data and unseen data. And black box nature, so basically it's the deep learning model are often treated as the black boxes, making it the difficult to understand how they work and they arrive at their prediction. Okay, so in this time we talk about the CNN because it is the convolution neural network, and it's very popular for the image classification, image segmentation, or object detection. Okay, basically CNN is a type of deep learning algorithm that is particular well suited for image recognition and processing tasks. It is made up for the multiple layer, including convolution layer, pooling layer, fully connected layer. And the architecture of CNN is inspired by the visual processing in the human brain, and they are well suited for the capturing the hierarchical pattern, and the special depends on the within images. And key components of the convolution neural network include such as convolution layer. Okay, so it's one kind of the key components of the convolution layer, CNN. And also pooling layer, we also need the activation function, also need the fully connected layer. So basically this four component is the basic component for the CNN. And convolution network, mainly these layers apply for convolution operation to input images using filter to detect the features such as age, texture, or more complex pattern. And convolution operation help the preserve the special relationship between the pixel. Okay, and further pooling layer down sample special dimension of the input and reducing the computation complexity and the number of the parameters in that network. And max pooling is common pooling operation and selecting in the maximum value from a group of the neighboring pixel. And activation function is very important for the non-linear activation functions such as the rectified linear unit and introduce non-linear linear the model and allowing to learn more the complex relationship of the data. And fully connected layer, mainly this layer are responsible for the making the prediction based on the high level feature learned by the previous layer, and they connected every neuron in one layer, every neuron in the next layer. So basically this is the basic components of that CNN. And convolutional neural network training, when you want to train the convolutional neural network, first of all you need the data preparation. Okay, so in the data preparation, the training images are preposed to ensure that they are all in the same format and size. And secondly, loss function. A loss function is used to measure how well the CNN is performing on the training data. And this loss function is typically calculated by the taking the difference between the predicted level and actual level of the trained images. An optimizer is used to update the weight of the CNN is order to optimize the loss function. And backpropagation, it's very important to technique used to calculate the gradient of the loss function with the respect of the weight of the CNN, and the gradients of the used to update the weight of the CNN using the optimizer. So in this time, CNN evaluation, how we can easily check about the accuracy about the CNN or other things. So basically, we can check the accuracy. Accuracy is the present percentage of the test image that the CNN correctly classifies. And then precision is the presence of the test image that CNN predicts as a particular class and that are actual of that class. And recall is the percentage of test image that are of particular class and that are CNN predict as the class. And F1 score, the F1 score is the harmonic mean of the precision and the recall. It is a good metric and evaluating the performance of CNN on classes that are imbalanced. So basically, this is the common things about that. But when you want to do for the practically, then we have to know a lot of library, lot of Python library or other things. So in this time, I talk about that how we can easily work with the real field. So today I will try to discuss about that how we can easily work this type of satellite imagery and ready for train our model. So basically in this time, how we can easily import this type of satellite imagery in our model and also import the sample. So let's go. I simply open my code editor. So first of all, you have to install the two Python packages. One is the rasterio, another is the artpy. So basically these two packages we need for installing for our work. One is the rasterio, another is the artpy. So just I simply install again because I already installed this thing. So that's why it show the requirement already satisfied. Further, in this time, we need to work with this type of package. One is that pandas package, numpy package, keras package, cross sequential, cross layers, cross callback, and also cross model, then rasterio, artpy. So this type of package we need for that further work, for that make the image classification. And then we can simply connect with our Google Drive. And in this time, we put our parameters. So basically in this time, we are just use this type of feature, this type of band. We are working as the parameters and also level, class, value, and sample we put in here. And this is our CSV file, which is including the sample. And this is our TIFF file. So I already imported this CSV file and also imported that TIFF image in our drive, in Google Drive. So here you can see. So just I simply create this folder and I already imported these things in here. Okay, you can see I put the CSV file and also this is my TIFF images. Okay, so further I run the code, then I can get this type of things. So now this image I want to visualize in here. So just I click to the run. So now it will be loaded this image in my Google Colab. So now I already imported my it's my imagery, and I already imported my sample, which is including the different types of pixel signature or spectral signature for the different types of band value, mainly B1, B2, B3, B4, this type of thing. So here I can get this type of imagery. Here you can hit show the true color composite. If you want, you can also use here the another. Suppose I just simply change it, the band combination. Suppose I put here that near infrared B5, then put here the red and put here that blue. Okay, so now click the run. In this time we can get the another band combination, mainly false color band combination visualized in here. You can see we can get this type of image collection. Okay, so you can easily use any kinds of band combination. You can simply change from here. Again, we also make the composite band combination between the 543. Then we can get this type of result. So as well as also you can see it's my CSV file. So basically I simply call the pandas library PD and read my CSV file. Okay, so here I can click the run. So now it show me all of those spectral signature or pixel value for each training sample or each training point here. You can get in here. So you can get the B1, B2, B3. So all of those training sample we can easily get from here. And we already make the train and testing sample from here. You can see we can use the some data for train and some data for testing. So then further we can spill the data set. You can see mainly we spill the data set train sample and test sample, and then spill the between the feature and level. We can simply put in here. So click to the run. So now it show you the result, how much training sample you can take and how much testing sample you can get from here for each classes. So here you can see you can get the train feature, test feature, train level, and test level you can get in here. So further, we are just use here this train data to train our CNN model, and then we are make our model for our data. So further tutorial I try to discuss about that how we can easily create the model. So mainly CNN model, okay, and then this type of train feature we are used for train our model, and test feature we are used for check our evolution about that CNN model. So today is no more. Further we discuss about our model, make the model, how we can easily create the model in CNN model, and then further we are just use the train feature and train our model, and also use the test feature to check about the evolution. So today is no more. I hope you can easily some basic knowledge about the deep learning. So further we will try to discuss about the more thing about the deep learning. In the meantime, anyone if you have any live training session, you can easily join with me for the deep learning with the land use, land cover classification, segmentation, and object detection. Then you can join. Okay. So today is no more. Thank you for watching that. Stay happy, stay safe.